So with this section, what we're going to be looking at basically is the double angle identities and the half angle identities, like that. Okay, so all of these things, I give you all of these identities. So if you can write a note to that, I think on that identity sheet that is on Canvas, 8.6, I give all the identities, okay, because these aren't going to show up quite as much. So I'll give you all these. So first thing we're going to look at is what we mean by a double angle identity tonight. If you do move on to calculus, I can think of lots of times when we use these identities, particularly that sine 2 theta. That shows up a lot, okay, in different things. So first thing I want to do is I'm going to kind of derive these identities for you. And you want to write down the derivation, because if you go to higher math like calculus, your teacher may not give you any identities. So that's why you want to be able to derive them just in case, all right? So let me show you how to derive this one. They're actually very easy to derive. So we're going to look at the sine of 2 theta. I'm going to establish that identity. Now here's what you have to do. You got to be kind of sneaky at the beginning, and you just say sine of theta plus theta, right? You agree that theta plus theta is 2 theta. All right, what do you think I'd do now? I got sine of theta plus theta. What do I do? Identity, right? Sine, cosine, cosine, sine, same sign. That's we're going to go ahead and use the sine sum identity. So write it down. It goes sine, first angle, cosine of the second, same sign, then it goes backwards. Then what you have is you go cosine of the first times sine of the second. Okay, that's the identity that we worked on in the previous section. Okay, what do you notice about these two things right here? Aren't they the same? So what do you have? How many do you have? You have 2. Okay, so what you have is you combine those like terms, and the identity would now pop out. So you would say 2 sine theta cosine theta. See, it's very easy to derive that formula. It's helpful to memorize it, but it's also easy to derive. If you remember step 1, that is. Okay, that's what you got to remember. Okay, let's go on to this one. I'm going to now establish this identity, and I'm going to do this in exactly the same way. When we do cosine of 2 theta, this is also a real easy one to derive. We say cosine of theta plus theta, like that. Okay, now what identity we'll learn for cosine? That's the one that goes cosine, cosine, sine, sine, different sine, right? So we put it in, and we see what comes out of it. So we say cosine of the first, cosine of the second, different sine, minus, then we say sine of first, and then we say sine of second. And the identity is staring you right in the face. What's a cosine times a cosine? Cosine squared theta. What's a sine times a sine? Sine squared theta, that's it. See how easy it is to derive those? Okay, and I forget these. If I don't teach a class in a long time, I forget them, but I remember how to kind of put these things together, okay? So then the next thing I want to look at is this thing right here. I want to establish this identity. This one's a little bit harder to do, so I'm going to do that one for you. And there's several ways to do this, but this is, to me, is probably the simplest way to do this. So what I'm going to do on this one is we're going to start off by doing tangent of 2 theta. Now you could do theta plus theta. You could do that. Or you could just do sine over cosine. Okay, it wouldn't matter. What I'm going to do is I'm going to just do sine of 2 theta over cosine of 2 theta, like that. I'm going to start that way. Okay, and then what I'm going to do is I'm going to use the identities that I already know. Okay, and sometimes I have to think about this a little bit to remember how this goes. There's actually 2 other forms of the cosine of 2 theta that are mathematically equivalent to that first one. So let's just do this. The sine of 2 theta is 2 sine cosine. So let's plug it in. Let's see where we get from this. So replace that with 2 sine theta cosine theta, like that. Okay, now let's see. For cosine of 2 theta, let me think about this for a minute. I want to use this one. So we're going to use this one. Okay, so replace the cosine of 2 theta with 1 minus 2 sine squared theta. See, that cosine 2 theta identity has 3 forms of it. but they're all mathematically equivalent, okay? All right, now what I'm going to do is I'm going to do this then, okay? Let me make sure I'm on the right track with this thing now. Sometimes I do this wrong. I thought I was going to do this in a different way. No, I think I'm okay. I am okay. Sorry about that. Okay, so what I'm going to have you do on this now is let's divide that by the cosine squared theta. Okay, both top and bottom, like that. Now I see how, I wasn't seeing how it was working for a minute, but now I see this. Okay, so what you can do is, see, you can take a fraction and you can divide everything in the numerator by something as long as you do the same thing to the bottom. So I'm going to go ahead and just write it like this, and then we're going to see what comes out of all this stuff. Okay, so I'm going to divide by that. Okay, like that, and let's see if I'm getting there. I'm almost there. Okay, it seems like I got one little issue, but I think it's going to work out. Okay, so here's what I see here. In the numerator, I'm going to write this as 2 sine theta cosine theta, and I'm just going to write down the cosine squared theta like this because I think you'll see it better if you do it like that. And then the denominator, I'm going to go like this. I'm going to write that down as, just leave that alone, 1 over cosine squared theta, and I'm going to leave that alone, and then there's one little issue that's going to show up, but I think it'll work its way out. Okay? All right, so here's what we have now. This one's a little bit harder to do. Let me see if you spot what I spot. Well, obviously, these cross out, right? And what is sine over cosine? What is that? Tangent, right? Okay, so that numerator is going to become 2 tangent of theta like that. And that's what it's supposed to be. In the identity, that's what we got. Okay? Now, in the bottom, what we have is we have this. And I probably have to go a little bit further. I didn't see some. I was missing something on this. So I'm going to go ahead and just write that as secant squared theta. I think it'll work out. This is a little different than the way I usually do this. And then this part right here is a tangent squared theta like that. So I have secant squared theta minus 2 tangent squared theta like that. Okay, so I'm almost there. Okay. Now we have an identity. One other thing that we could use, and then I think it'll all work beautifully. We have the identity that says tangent squared theta plus 1 is equal to secant squared theta. So what I'm going to do is I'm going to replace this thing, the secant, with this, and then I think it'll finally give us what we're trying to get. So this is going to be 2 tangent theta, replace secant with tangent squared theta plus 1, minus secant squared, no, not secant squared theta, I'm looking at the wrong thing, minus 2 tangent squared theta, and then I think I'm finally there. Okay, like that. This is a pretty tough one. So that would be 2 tangent theta. I have 1, and then tangent minus 2 tangent is tangent squared theta. Okay, like that one. Okay, so that's it. That's how that works. I think there's an easier way to do that. That's just kind of playing with it, and that's what I come up with. So by changing it to sine over cosine, and then using some basic identities, it works out. Okay? Now I'm not requiring you to know how to do that derivation, but just to kind of show you, part of the point of establishing identities is in mathematics, that's how we get more formulas, is by working with identities. Okay? It leads us to other places. Okay? That's the idea. Okay? Okay, so let's finish up here tonight with just maybe one last idea here. And what I'm going to do with this one is we're going to work with just one of the identities. We're going to work with the sine of 2 theta. And you use these identities more for proofs and for other things. You don't really use these on the unit circle very much. So what I'm going to do with this one is our job is to find the sine of 2 theta based on this piece of information that I gave you. I've given you enough to figure that out. So the first thing that you'd want to do is you would want to say, okay, I'm doing a sine of 2 theta, so I'm going to pull out that identity right there. Okay, so that's equal to 2 sine theta cosine theta like that. Okay, and I've given you enough information to know what the sine and the cosine is in this problem. Okay, so here's what we do. It's back to this triangle stuff again and basic definitions. Okay, so if I give you a cosine, what are the two letters that I have given you? What's its definition? X over R. Okay, notice that I've also given you the quadrant. What quadrant am I in based on that piece of information? Quadrant 4. Everybody with me on that? 3 pi over 2 to 2 pi is quadrant 4. So if you're in quadrant 4, x is positive and y is negative. Okay, so you have to know that. So it looks like x is going to be 20, r is going to be 29, and again we're in quadrant 4 on that. So we just need to figure out y. Now this is Pythagorean Theorem. I'm going to do this on the calculator in one step. And you want to get to a point when you have to do Pythagorean Theorem, you just get your calculator out and do it that way so you don't have to write anything on your paper. So I go r squared, 29 squared, minus the 20 squared, because you're subtracting when you're doing it this way. That'll give you that, and then you do the square root of 441. So if you do the square root of 441, that's, I think, 21, I think is what that is, I think. Yeah, 21. So that would give y is equal to negative 21. Okay, if you have any problem doing that on your calculator, just write down the steps. Okay, so now we're ready to finish the problem. It's actually very easy to finish. Okay, look at this information right here. Tell me what the sine of theta is. Y over r, so what is it? Negative 21 over 29, right? Okay, so that's going to give you negative 21 over 29. Hey, what's the cosine of theta? 20 over 29. It's x over r, so that's 20 over 29 like that. Then we just probably need to multiply this out with the calculator. There goes the light again. Okay, so I'm going to do 21 times 20. And I got to double that because I'm going straight across. So if I double that, that looks like that's going to give, what, negative 840 is what goes there. Then I just need to do 29 times 29, or you can do 29 squared. And that's going to give 841. Weird answer, but that's the right answer. So it's negative 840 over 841 like that. So what I've done with this is, again, I've pulled out the identity, and then basically I have enough information to know sine theta and cosine theta. So it's back to triangle and basic definition stuff, okay? That's not that bad. What do you think? Okay, getting comfortable with these identities. So that'll wrap us up for tonight. I'll stay after class a little bit if you have some questions too.